Okay, this is the paper for Feb March 2024 variant 1-2. Let's start the solution. The first question suggests that find the exact value of 2 by x square d of x when the limit are 3 to infinity. So first of all, write down the integral 3 to infinity 2 by x square d of x. That could be written as 2 could be taken out because it's constant, 3 to infinity x to the power minus 2 d of x. Definitely power rule of integration will be applicable over here. So you will have 2 times by x raised to the power minus 2 plus 1 over minus 2 plus 1 because of the power rule of integration. Upper limit is 3, upper limit is infinity and lower limit is 3. So that could be written as 2 times x raised to the power minus 1 by minus of 1, 3 to infinity, 2 times minus could be taken outside, 1 by x, 3 to infinity. Let's plug back the limits. Minus 2 times the upper limit, 1 by infinity, minus 1 by 3 the lower limit. As you know that 1 by infinity is always equals to 0 and 0 by infinity is equals to also 0, or you can say 0 by 0 is equals to infinity. These are some rules. These are obvious proofs. So by using that thing, 1 by infinity is equals to 0. I can suggest this term will die and I have minus 2, 0 minus 1 by 3. So that becomes minus 2 times 0 is 0, minus minus become plus 2 by 3. So the total area under the curve would be 2 by 3. That will be the answer. Okay, next is question number 3. Showing that dy by dx is equals to 3 times by 4x plus 5 whole to the power 1 half. The points are 1 and 9, 5 and a lying on the curve. Find out the value of a. That is your x, that is your y. For example, as a whole, this whole point seems to be p. For the other point, this is x and this is y, and as a whole, this point is known as q. It means that p points x and y are given to me. Q points x is given but y is unknown. I have to work so far. So I have to find the value of q point that is containing at the position of y, that is seems to be a. So let's start the solution. Dy by dx is equals to 3 times by 4 of x plus 5 whole to the power 1 half. I need to find the value of y, and this is the curve that initial points and final points are given to me. So it means that I have to integrate this expression. Once I integrate this expression, my final answer reduced to dy by integral dx could be shifted on to the other side, and that becomes 3 times 4x plus 5 whole to the power 1 half d of x. I have to apply the integration. So that d and that integral will cancel and y will reduce into 3 times integral of 4x plus 5 whole to the power 1 half d of x. I took 3 outside because of the constant term. So y is equals to 3 times 4x plus 5 raised to the power 1 by 2. Power rule will be applicable. So that becomes, before applying the power rule, I have to multiply 4 and divide 4 because the derivative of inner function, that is basically my 4x, it's 4. So 4 is not present over here, so I will multiply and divide with 4 so that I can work the power rule. So divide by 4 and times by 4. Now it's fine. I can use the product rule now, or power rule now, power rule of integration. So 3 by 4, 4x plus 5 whole to the power 1 by 2 plus 1 dividing by 1 by 2 plus 1. Upper lower limits are given, that are 1 to 9. I will use later. So that y becomes, y is equals to 3 by 4 times by 1 by 2 plus 1, that becomes 1 plus 2, that becomes 3 by 2. So once I write 3 by 2, that shift that term 3 by 2 over the numerator, that could be written as 2 by 3 times by 4x plus 5 whole to the power 3 by 2. Okay, that 3 and that 3 will cancel, and y could be written as 2 by 4, that further could be written as 1 by 2, 1 by 2, because 2 times 1 is 2 and 2 times 2 is 4, times by 4x plus 5 whole to the power 3 by 2 plus some constant of integration that is known as c. I will find the value of c first at the point 1 and 9. So at some point, what is p value? 1 and 9. At some p 1 and 9, I can find c by putting this point in equation number 1. So let's plug x is equals to 1 and y is equals to 9. 9 is equals to 1 by 2 times by 4 times x is 1 plus 5 whole to the power 3 by 2 plus some constant of integration that is known as c over here. So once I put down all the values together, I am able to get 9 is equals to 1 half 4 plus 5, that would be 9. So inside the bracket I have to plug 9 to the power 3 by 2 plus some constant of integration c over here. Okay, so 4 times by 1 plus 5 dividing by 2 and the value of c. Yeah, that's fine now. So 9 is equals to 1 half. 9 could be written as 3 square. 3 square whole to the power 3 by 2 plus c. This square and this square will cancel, and I have 9 is equals to 1 by 2, which is equals to 3 square, 3 cube I meant. 3 cube is 27, so here would be 27 plus c. Once I solved for c, I have 9 minus 27 by 2. And once I took the LCM, at the end I have the value of c, that is minus 9 by 2. Up to this point I get the value of c, that is minus 9 by 2. Now I have to use this value back to the equation number 1. So at the place of c I can write y equals 1 by 2. Let me write with some other marker. So that is the value of c. So put back in equation number 1. So I have y is equals to 1 by 2 times by 4x plus 5 to the power 3 by 2 minus 9 by 2. That's the expression for y I have. Now I have to work for the value of other point, that was a. I can use that point now. Now put q is equals to, q point is what? It's 5 and a. So 5 and a. What I will do, at the place of y I will use a, that is what? That is actually my y. X is what? X is actually my 5. So then put back into the expression to get the value of a so far. So at the place of y I will write a, that is equation number 2. Let's mark it. Put 5 and a in equation number 2 and I have a is equals to 1 by 2 4 times of 5 plus 5 raised to the power 3 by 2 minus 9 by 2. Once you solve it, you had value of a would becomes 1 by 2 times by 20 plus 5 raised to the power 3 by 2 minus 9 by 2 raised to the power 3 by 2 minus 9 by 2, and the value of a will become 1 by 2 25 raised to the power 3 by 2 minus 9 by 2. Once you solve it, at the end your value for the a will become 25 could be written as 5 square. Square and that square cancel. 5 cube will become 1 to 5. So 1 to 5 dividing by 2 minus 9 by 2. And the value of a will become 58. It means that you get the value of it that seems to be 58 over here. That will be the answer for this question number 3.